Hello and welcome. We're still on section 2.13, section 2.13. I just want to do a quick video on clearing fractions and decimals. It's just a little trick you can use to make our equations a little bit more palatable. You don't have to do this. If you have a calculator, you can get away with not doing it. But, if you're doing some work by hand, which you probably want to be doing anyway, it's not a bad thing to know how to do. It makes life easier in some ways. So I'll just give you a couple examples and we'll see. You'll see what I mean. So I'm going to start with an example from the book. I'll just write it right here. I'll start with this equation. Let me see what it is. 0.52 times x minus 2 plus 0.66 tenths equals 1.29. Now, out of the gate, this kind of looks kind of obnoxious. A lot of decimals that you'll have to worry about. We can deal with these decimals right now by looking at how many decimal places each of these decimals have and find out which one has the most decimal places to the right of the decimal. Well, looks like we've got two decimal places. And so we just multiply by the power of 10, 10, 100, 1,000, etc. That will basically move that decimal point two places. And it will move all these decimal points two places. As you'll see, distributive law applies on everything. You'll see how that works. So I'm just going to do that. I'm going to multiply both sides by, you got to multiply the entire side, not just one term that you want to get rid of, that you want to deal with. You have to multiply the entire side by 100. Okay? And so what happens? Well, on the left side here, we've got two terms, one term here and one term here, right? So this 100 distributes to this whole term, which basically effectively means it will just multiply by the 0.52. You'll see that. And then it will distribute also to the 0.6. The right side, it will be pretty straightforward. So let's do that. 100 times 0.52 times x minus 2 plus 100 times 0.6. And that equals, well, we might as well do this math right now. 129 times 100 moves the decimal place twice. So this is 129. So already that number is looking a little bit nicer. What does it do to the 0.52? So you don't multiply this 100 by everything. In some sense, it does distribute still into this x minus 2, but first it will multiply by the 0.52 right now and move the decimal place to the right by 2. For every 0 you multiply in your power of 10, you move the decimal to the right. Yeah, let's do that. So that makes this 52 times x minus 2 plus, now 100 times 0.6, 6 tenths, that will move this decimal place 2 spaces to the right as well, which means there will be a 0 here. So this ends up being just 60. All right. Now we can distribute this 52. So we get 52x minus 52 times 2 is 104 plus 60 equals 129. Okay, so now we need to do this little arithmetic here to combine the negative 104 and the 60. So negative 104 plus 60 is 44. And we still have the 52x here. So it's negative 44 there. 100 equals 129. So now we can add 44 to both sides. 129 plus 44 should be 173, as I expected. 173. And we have 52x. I'll just bring this over here to the right. Notice I'm trying my best to line up these equal signs. It's not necessary, but it makes for a cleaner solve. Anyway, dividing both sides now by 52, right? X equals this number. Now this number, you may not know this, but if you check your calculator, try factoring these things. Like 52, if you divide this by 2, you get 26. So it's really, 52 is 4 times 13. So all you have to do is check if 173 is divisible by 4, or well, it's divisible by 2, which it isn't, obviously, because it's an odd number. So really, you have to check if it's divisible by 13, and it isn't. So really, this answer that's the complete answer. Now, since the numbers in the problem had decimal points, you might want a decimal answer, but it ain't pretty. So we're gonna do this. Basically, once you do that division, you get about 13.30, I don't know, 8, something like that. You don't have to round to that many decimal places. I'm just being careful. Anyway, so it depends on your problem what you need. So that's the basics of clearing decimals. Basically, you find the number of the decimal that has the most decimal places here or here to the right of the decimal, 2 decimal places, and then you multiply both sides by that power of 10. You know, that will clear that decimal place. Move it to the right, so you're just working with integer coefficients. That's really nice. Now the numbers are bigger and they're somewhat obnoxious, but you know, better that than decimals. So it's kind of a trade-off. Anyway, so let's look at this with fractions. Let me get another problem from the book here. 2/5 x minus 1/3 times x plus 1 equals 2/9. Oops. 2/9 x minus 5. Now, I don't know about you, but all these fractions here are kind of making me nervous. You can work with it. You can distribute the negative 1/3 through here. That's fine, but then you're going to have to deal with subtracting 2/5 and 2/9 at some point. Not fun in general. So let's think about what we would have to do to kill off. What would we multiply to kill off this 5, this 3, and this 9 in the denominator? Well, I just need to find a number that's divisible by all 3 of those numbers, and it will cancel with all those numbers, and partially cancel with those numbers. It will basically kill off these. So, for example, if I multiplied both sides by 9, it would cancel with this 9. If I multiplied both sides by 5, it would cancel that 5. Now, instead, all I need to do is find a number that is divisible by all 3 of those numbers. So, and if I can find the smallest such number, that's the best. That's called the least common denominator of all denominators. You just multiply by the LCD of all the denominators. In this case, the LCD of all denominators is 45. 9 times 5 is 45. That's already divisible by 3, so we don't have to multiply by 3 again. So 45 is our best choice. Yeah. So let's do that. Multiply both sides by 45. Oh boy, I'm just going to put this on the right side. Since commutativity, we can put it on the right side. Okay, so now the fun begins. So I'm just going to write this out. You can kind of do some of this on the fly and cancel on the fly as you get better. But this 45 has to distribute to this term and to this term. Now remember, this whole thing here is a term. We'll do that distribution into the x plus 1 later. But for now, we're going to distribute into both of those terms on this left side here. So this is 45 times 2/5 x. Yeah, I'll stick with minus 45 times 1/3. I could have written this as plus 45 times negative 1/3, but I think it'll be fine like this. Times x plus 1. Now let's do 45 multiplied by both of these terms. So 45 times 2/9 x minus 45 times 5. All right. Okay. Now this seems kind of messy, but remember, you might be able to skip some steps as you go, because all you need to notice is that 45 divided by 5 is 9. And so that kills off that 5, and you just have a 9 on top, if you will. 9 times 2x. And again, 45 divided by 3 is going to be 15. 15 times 1 is 15, so I'll just write that. On this side, we have 45 divided by 9, which is 5. 5 times 2, just to see how you can take some shortcuts. 5 times 2 is 10, and don't forget the x there. And then 45 times 5, which I believe is 225. 450 divided by 2. So I'll write this as 18x minus this 15 distributes to the x. This negative 15 distributes to the 1 as well, so it's minus 15. So this is the same over here, 10x minus 225. Now we can collect some like terms. The 18x minus 15x should give us a 3x minus 15 equals 10x minus 225. And now this is, I don't know about you, but this is way nicer. I mean, basically from this point on, this is a way nicer problem to deal with than all of those fractions. I don't know about you, but this is a game changer. The only difficulty is doing this distribution up here. But you know, mathematicians like to do more work to avoid work, so this is a nice little trick. All right, so let's finish this. I guess I'm going to subtract 3x from both sides. It doesn't really matter which way you go, but I'm going to bring the x's to the right side, and I'll add 225 to both sides as well. Kind of doing both of these steps at the same time. So on the right side we have 7x. On the left side the x's cancel. On the left side we've got 225 minus 15, which is 215 to 10. Now I like to do this last, just one division at the end. Don't have to worry about anything else. No weird fractions to deal with, except at the end. And this 210 divided by 7, well, that's not too bad. That's just 30. So x is 30. I switched it around. X is 30. And that's it. I think that's it. I can do more examples if need be. But for now, thanks for watching. See you next time.